Hey guys, this is going to be me going through every problem for the review. So fast forward, pause, skip ahead to whatever it is you need to go over. Starting with chapter 1 here. It says justify each step by naming the property. So this first one, this is the commutative property of multiplication. Remember when you just flip-flop where things are like that, you're not changing what is in the parentheses, but just the order of those two things. That's the commutative property. Then to get to the next step, now it went from this where you're multiplying this part first to they moved the parentheses. So that's the associative property. Again, of multiplication. And then the next one, you are multiplying 4 times 1/4 and it becomes 1. That's the inverse property, right? 4 and 1/4 are inverses. When you multiply inverses, you get negative, or you get 1 from that. So this becoming a 1 is the inverse property of multiplication. And then 1 times -3 being -3, that's the identity property, right? If you multiply something by 1, you get that same thing back of multiplication. All right, number 2, evaluate for the given value of the variable. A is 5. Now this is always the thing that tends to be done wrong. It is saying the opposite of a squared. It is not saying the opposite of a squared, okay? That is not it. It is saying square a and then take the opposite of that, okay? So when there's not parentheses around it, that negative gets attached on at the end. So this is the opposite of 5 squared plus 4 times 5 minus 17. So this is the opposite of 25 plus 20 minus 17. And as soon as you have addition and subtraction as your only things left, then you just go left to right. You can literally plug that into your calculator if you want, and that comes out to a -22. Number 3, you have an S value of 3. So we're going to drop that 3 in. Okay, so it looks like this. PEMDAS says that we should do what is in the parentheses first. So that's going to become 6 times 1, right? 3 minus 2, minus 4 times 4 over, we'll do 9 plus 1. Keep going a little further with that. You get 6 minus 16, multiply before we subtract, over 10. And then remember the division bar acts like parentheses. So you actually want to just do the subtraction here first. So 6 minus 16 is -10 over 10, which is a -1. Number 4, the expression that you see there models the daily cost in dollars of renting a car. In the expression, X represents the number of miles the car is driven. What is the cost of renting a car for a day when the car is driven 50 miles? So if X is representing the cost of renting a car for, X represents the number of miles the car is driven. What they're saying is X is 50, right? So if you have this expression, it's just a matter of plugging it in. 1995 plus 0.02 times 50. And if you just plug that into your calculator, you get $20.95. Number 5, solve the equation. So we want to get our like terms together. So this is 2r, our equal sign is here. I'm going to add the 2.5 to both sides. So 2r equals 6.2, and then divide by 2. So r is 3.1. Stuff feels too easy now, huh? You guys are so smart. All right, this one, distribute. So you get 15t plus 6 equals 36. If you are someone who prefers to divide by 3 right here off the bat, you totally can, but you don't have to. I'm not going to do that way because I feel like most people always distribute first, but you absolutely could just divide by 3 as well. Take away the 6, so you get 15t equals 30, and then divide by 15, so t is 2. Okay. Okay, number 7 says solve the equation for x. State any restrictions of the variables. For this one, you are trying to solve for x, and there's an x in both. So here's how I tell people to think about this. If I gave t and u numbers, we don't know the numbers, but let's just pretend. If this was 5x minus 2x, okay? If these were numbers instead, we would take this number minus that number, right? And we would call it 3x. Well, this is not numbers, but that's still what we want to do. So we want to take the t minus the u, but that's still going to be multiplied by x, right? So that'd be like saying 5 minus 2 times x, okay, equals 3t. And if we're solving for x, then we want to get rid of that t minus u. So we're going to divide by t minus u. So we get x equals 3t over t minus u. Okay, then it says to state restrictions. This one's a little trickier than some of the others that we've done with stating restrictions. You cannot divide by 0. So the only thing that would make this denominator 0 is if your t value was equal to your u value. So your restriction is t cannot equal u. 5 minus 5 would be 0. 7 minus 7 would be 0. So as long as t doesn't equal u, you are good. Number 8. Again, we're solving for x. So I'm going to get this 3 out of here first. So it's x minus 3 over 6 equals a minus 3. And then we are going to multiply by 6. But you got to multiply this whole thing by 6. So 6 over 6 is 1. We're left with x minus 3 equals. At this point, you can distribute right away, or you can finish the problem and then do the distributing. I'm just going to distribute. So this is going to be 6a minus 18. And then your last step is add 3. So x equals 6a minus 15. And you're done. All right, number 9. Solve for the indicated variable. So they're telling us to solve for r sub 2. So the first thing we would do is get that 1/2 out of there. I wouldn't distribute that. If you distribute it, it's goofy, more work in the end. I would just multiply by 2 on both sides so that this goes away. So now you have 2r equals r sub 1 plus r sub 2. And we are trying to solve for r2. So we would just take away the r1. So we end up with 2r minus r sub 1 equals r sub 2. Okay. Number 10, we are solving for L. So let's start by getting the 2w out of there. So it's p minus 2w equals 2l. And then to solve for L, we're just going to divide by 2. So L is equal to, now technically you could leave it like this. I'm okay with that. Or if we're going to simplify that further, technically we could do this. But then if we're going to do that, we got to keep the 2 with the p also. So you would have to do p over 2 minus w, right? 2 over 2w would be just w equals L. So I don't care if you leave it like that, or if you want to leave it like that, that's okay too. All right, solve and graph. So we're trying to isolate the m. So we will take away the 7, and we get 3m is greater than or equal to -3, and then divide by 3. ask yourself the question, do I flip my symbol right here? There is a negative, right? But we didn't divide both sides by a negative. We divided by a positive, so we don't flip. So m is greater than or equal to a -1. And the graph of that would look something like this. So if this is our -1, greater than or equal to is a closed dot, and it goes to the right. Remember we said you can turn this into an arrow, whichever way it's pointing, as long as your variable is first. Okay, number 12 is a little bit fancy here, but that's okay. You've got this. So I would probably distribute the 3. So 4a is greater than 3a plus 3. And then I would distribute this negative. It's like a -1, right? So -1 times 7 would be a -7. And then -1 times a -3/2 a would be plus 3/2 a. So you're here. Now you can start combining some of these like terms. 3a plus 3/2 a. Depends how you want to see that. It's 4.5, right? Or 9/2 a. I would probably just call it 4.5a. But you don't have to. You can leave it as a fraction if you would like. And then 3 minus 7 is a -4. And then we got our 4a over here. So now you have options. If you want to move the 4.5a over, that's fine. Just in the end, you'll have to flip your symbol. If you decide to move the 4a over and move the 4 over here to the left side, then you wouldn't be flipping, but either way, you're still going to get the same answer. I'm going to do the flip just because I feel like that's what, when I tend to ask people, they would do as their step. So this is going to be a -0.5a is greater than a -4, and then we're going to divide by a -0.5. Here's where you got to be careful. We divided both sides by a negative, so it's a is less than, flip it over, okay? And then be careful with this. I would plug it into your calculator. People see this and they go -4 divided by -1/2, and they call it 2. But this is not 2. Dividing by a half is multiplying by 2, so it's actually 8. So just be careful with that. A is less than 8. And then when we graph that, you would put an 8 here. That's an open dot, and less than to the left. So it'll look like that. All right, 13. Solve the compound inequality, graph the solutions. These you solve separately. So you're going to add, sorry, you're not adding 6, you're adding 1 to make it 6. So 3x is less than or equal to 6, divide by 3. So x is less than or equal to 2. Or, now solve this one. You could go either way. We'll just do it this, so it's one less step. Take away a 2x, so you get -4 is greater than or equal to a -1x, and then divide by -1. I'm going to do it this way because it's going to get a little confusing, but I just want you to see what all needs to happen. So this is a +4, but we divided by a negative, so we would flip it. Here's our x. But if you want to write it the other way, then you would flip it back again. X is greater than or equal to 4. So I don't need it to be that way. I would say this is the best answer, but if you left it like that, it's not the end of the world. And then when you graph that, or problems, remember like the oars in a boat. So you have a 2 and you have a 4. These will both be closed dots because they have the bars. Less than or equal to 2, greater than or equal to 4. So they go away from each other like that. All right, 14. You're dividing by a negative, so flip it. So t is greater than or equal to -4. And divide by a negative. T is less than 3. So this is an and problem, right? You can write this. -4 is less than or equal to t, which is less than 3. Essentially, we're saying everything between -4 and 3 would be our solution. So if this is a -4 and this is a +3, It's going to be open at 3. It's going to be closed at -4. And we're going to shade everything in between. All right. 15 here says solve and then check for extraneous. When you have absolute value involved, there will be 2 equations. What you need to do is set the equation how you see it, just without the bars, but then also set it so that that could equal the opposite of that value, so -5, and then solve them both. So you're going to take away 3. So 2x equals 2, divide by 2, so x equals 1. Then you're going to subtract 3 here. So 2x equals -8, and divide by 2, so x equals -4. Do you remember how you check for extraneous on these? You just plug them back in, right? So if I plug a 1 in here, 2 times 1 is 2, plus 3 is 5. So this is saying the absolute value of 5 equals 5. That checks out. Plug in a -4. So 2 times -4 is -8. -8 plus 5 is a -5. And if we take the absolute value of that, it is a +5. So those are good. No extraneous there. 16, very similar, but a little bit different. You have absolute value isolated, right? The idea is we want absolute value by itself. So if there was anything back here or up here, you would have to get rid of it before we set up the 2 equations, but there's not on this one. So we're just going to set up the 2 equations. X plus 6 equals 2x, and x plus 6 equals the opposite of 2x. So take away an x, and 6 equals x. This one, take away an x, and 6 equals -3x, divide by -3. So x equals -2. So you get a 6 and a -2. Now you plug it in. This one, if you stop and look at it, maybe you can see it right away. If I plug a -2 in there, 2 times -2 is a -4. And the absolute value of something cannot equal a negative. So you should be able to see right off the bat that this is extraneous. Okay. If you plug in a 6 here and here, I get the absolute value of 6 plus 6 equals 2 times 6. So that's 12 equal to the absolute value of 12. That one checks out. So this is a true solution. This solution is extraneous. Okay. And then we threw lots of multiple choice questions in since a lot of your final exam is multiple choice. So here is one of those. Which of the following numbers is an integer, but not a natural number? The natural numbers, remember, those are the counting numbers. 1, 2, 3, 4. Integers are those, the opposites of those, but also any whole number, which would include 0. So technically this is the number 3, that would check out. This is the number 7, that checks out. This is not an integer or a natural number, but B is an integer, but is not a natural number. All right, this one, listing them from least to greatest, this is really just a matter of paying attention to detail, right? You have a negative, here's a 0, can't be that. Again, 0, this is going from greatest to least, can't be that one. You can check this B, but like right off the bat, -1, and then this is -1.5. It's actually a smaller number than -1, right? So it's not that one. This one actually works. If you plug those into your calculator, you'll see what the square root of 2 and the square root of 3 are, and 1.5 does fall between those two numbers. So C would be your least to greatest. Okay, this one says, which of the following is not equivalent to that? Really what I would do here is I would just simplify all of them as much as I can. So this is 4 minus 8x plus 10 minus 2x. Sorry about that. So then we're going to go negative 8x minus 2x. That's a negative 10x. And then 4 plus 10 is 14. So this is the goal. Okay. If you look here, that is the same. So that's not the one that's not equivalent, right? Negative 8x minus 2x is a negative 10x. 4 plus 10 is 14. So that one is the same. So that's not equivalent. This one, negative 8x minus x, that's a negative 9x. So that right there you can see is not equivalent. So you don't even need to check the last one. I probably still would just to be safe. 10 and negative 10x would get you 14 minus 10x. So that one's good. C would be your answer. All right, number 20. What is the value of absolute value of x plus 3 plus 5x minus 7 if x is negative 9? And this is just a matter of plugging it in. So it's the absolute value of negative 9 plus 3 plus 5x. Sorry, we know x plus 5 times negative 9 minus 7. So this is negative 9 plus 3, or negative 6, taking the absolute value of that. So this is going to be 6 minus 45 minus 7. Okay, and then at that point, you can just plug that into your calculator. You would get a negative 46 on that. Okay. 21. The expression 20,000 minus 1250 models the value in dollars of a piece of equipment t years after purchase. What is the value of the equipment after 8 years? So really all you're doing with this is plugging an 8 in for your t value. So this is going to go here, and then you can plug that into your calculator. You should get $10,000. All right, this one, brackets are just another way of doing parentheses. It's kind of like we put parentheses inside of parentheses, so we turn them into brackets. On this one, the thing that you need to be a little bit careful with is inside the brackets here, it's x minus that whole thing. So you can turn it into x minus 3, but then that negative one is essentially getting distributed. So that would be plus 2x plus 5. So simplify that. X plus 2x is 3x. So this is 4 times 3x minus 3 plus 5. So that's going to be 12x minus 12 plus 5, which then that simplifies to a negative 12 plus 5. So 12x minus 7 would be your whole left side. And then this one, distribute that, 3x plus 33. So take away your 3x, you get 9x. Add your 7, you get 40. So we end up at 9x equals 40, and then divide by 9. That's not a nice number, so we're just going to leave it as 40 over 9. 23. Which number is not a solution of this inequality? I would solve the inequality. You could plug every single number in and see if it's true, but I think it's a lot easier if you just break it down first and solve it. And then you can just see what every number you're working with is. So I would do, what would I do? I would actually probably, well, I feel like most people would probably distribute this. I think it's easiest if you just divide everything by 3 right now. So you would get negative 9 is less than or equal to 1 minus 2x, which is less than or equal to 1. And then take away 1. And make sure you do it on all the sides. So negative 10 is less than or equal to negative 2x, which is less than or equal to 0. Now here's where it gets fancy. We're dividing everything by a negative, right? So that means everything flips. So this is going to be 5 is greater than or equal to x, which is greater than or equal to 0. So really, it's best written like this. Okay. So this says, which is not a solution. So 0 works because it's got the equal to bar. -1 does not. 1/2 would work between 0 and 5, and 4 would work between 0 and 5. So your solution is the one that does not work in that setup, which is a -1. All right, 24. Which number is not a solution? Again, you could set this up and solve it, or you could just plug these in. I kind of think this one's easier just to plug it in as you go. If we plug it in, this is saying the absolute value of 5 plus 5 equals 5 plus 5. So the absolute value of 10 equals 10. That is true, so that works. 0 plus 5 absolute value equals 0 plus 5. So 5 equals 5, right? That one works. A -5, so absolute value of -5 plus 5 equals -5 plus 5. So the absolute value of 0 equals 0. That works. Looks like it's going to be this one. The absolute value of -10 plus 5, so that's the absolute value of -5, equals -10 plus 5, which is -5. Absolute value can't equal a negative, so that is your solution. 25, which of the following equations have more than one solution? If you look here, okay, absolute value bars equaling a negative, that is no solution. Okay, so it's not going to be that one. This one, if you were to solve, you get one answer, right? So it's not going to be that one. Same thing here. If you solve this one, you get 2x. Oh, interesting. Oh, yeah, you can do both. I was like, wait, there's two answers. There are two answers. 2x plus 1 equals 2x plus 1. If you take that away, you get 1 equals 1. Remember what that is? That's infinitely many solutions. Okay, so this has more than one solution, but so does this one, because you can go x minus 3 equals 4, and you can go x minus 3 equals -4. So often with absolute value, you can have multiple solutions. Not always, because this one over here didn't, right? But your solution here would be 1 and 2 both have more than one solution. Okay. All right, that's chapter 1. Okay, on to chapter 2. This says find the domain and range of each relation and determine whether it's a function. Remember, we put domain and range. The domain is your x values. The range is your y values, and we always put them in the little brackets. We put them in order with no repeats. So 2, -4, 1, 2, -1. So you're going to go -4, -1, 1, and 2 for the domain. And then for the range, 1, 5, 7, -3, and 2. So in order, that's going to be -3, 1, 2, 5, and 7. And then determine whether it's a function. Remember, if you have any repeat x values, it is not a function. And we have a 2 and a 2 here, so this is not a function. Okay. Number 2, it says state your domain and range. So again, it's essentially listing all of these points. So you have a point here, point here, point here, point here, point here. So your domain would be the x values. I don't typically make you name a domain and range from a graph like this, so I'm not real concerned about this part of it, but being able to tell me if it's a function or not is what I want to make sure of. So this would be the point -3, 2. The point, this graph is kind of awful, huh? -1, -2. The point 1, 1. The point 2, 1. and the 0.3, negative 3. So from all those points, your domain is going to be your x values. So negative 3, negative 1, 1, 2, and 3. That's lovely. Oh yeah, because I went left to right, so they're in order. Fantastic. So that's your domain. Your range is going to be the y values. So you have a 2, you have a negative 2, a 1, and a negative 3. So it's going to be negative 3, negative 2, 1, and 2 will be your range. And this one is a function because it passes the vertical line test. You don't hit any 2 vertically. So this is a function. Okay. All right. Number 3. It says, suppose you have f of x and g of x there. Find the value. So f of 2 is saying plug a 2 in for your x. So the function of 2 is 3 times 2 minus 4. Remember, this is like saying y equals. So f of 2, your y value when your x is 2, is 6 minus 4, or 2. So you would just write it like that. The second one is adding 2 separate functions together. So f of 1/3, and maybe you want to just separate these. F of 1/3 is 3 times 1/3 minus 4. So 3 times 1/3 is 1. 1 minus 4 is negative 3. So f of 1/3 is equal to negative 3. Then it says g of negative 2. So g of negative 2 is the absolute value of negative 2 plus 3. So that's going to be 2 plus 3, or 5. Okay, but now look here. It's saying take this and add to it that. So negative 3 plus 5 will be your solution here, which is 2. Okay. This one says f of 1 divided by g of 1. So if we plug in f of 1, that's going to be 3 times 1 minus 4. So f of 1 is, I'm just going to reset it up here. F of 1 is 3 minus 4, or negative 1. Okay, so that's the top number of our fraction. And then g of 1 is going to be the absolute value of 1 plus 3. So 1 plus 3 would be 4. So negative 1 divided by 4, or a negative 1/4, would be f of 1 divided by g of 1. Number 6, the diameter of a tree varies directly with its age. A 15-year-old tree has a 3.75-inch diameter. How old will the tree be when it has a 25-inch diameter? So I would set it up age over diameter equals age, and there you said how old, so that's our unknown, divided by diameter. Okay, so it looks like this, and then you are going to cross multiply that. So when you do that, in the end, 3.75 equals whatever that comes out to. Sorry, 3.75x. I don't even know what that is. Divide by 3.75, whatever this number is when you multiply it. And it comes out to 100. So that tree would be 100 years old. Okay. Sorry, that was 375. This number 7, it says find the slope of each line. Remember, slope formula is y2 minus y1 over x2 minus x1. So this would be x1 y1 and x2 y2. So it's going to be y2 minus y1 over x2 minus a negative 2, which is actually plus a positive 2. So 1 minus 7, or negative 6. 4 plus 2 is 6. So that comes out to a slope of negative 1. Then it says find the slope of the line that's perpendicular to this line. Remember, the only thing we care about in finding a perpendicular is the slope. So if currently your slope is 3/2, remember, perpendicular slopes are opposite reciprocals. So the opposite reciprocal of 3/2 means you flip it over 2/3 and change the sign. So that's going to be a negative 2/3. Okay. Number 9 says use standard form to write the equation of the line with the given slope through the given point. So what you're going to do here is set it up, I would say, in point slope form first. I think that's the easiest way, but you might disagree. Maybe you want to start with slope intercept form, but ultimately we're getting into standard form, okay? So it's going to be y minus y1 equals m times x minus x1 to start, but in the end we want it to look like this. ax plus by equals c. So we're going to go y minus 2, right? This is your y value, this is your x value, equals the slope times x minus a half. And then I would distribute that. So y minus 2 equals 6x minus 3. And then standard form, what would I do here? I would probably move the y this way and the negative 3 this way. So you would have 6x minus y, and then when you move the 3 over plus 3, you'd get a positive 1. Now, if you ended up with going the other way, a negative 6x plus y equals negative 1, it's technically the same equation, but less negatives is typically the preferred route. So I would do it this way. Same thing on number 10. You have a point and a slope. So I'm going to put that into point slope form. Y minus 3 equals 1/4 times x minus 4. And then distribute. So y minus 3 equals 1/4 x minus 1. Remember with, maybe I wouldn't do it that way. Yeah, it's fine. With standard form, we can't have fractions. So again, I would move the y over. So I would have 1/4 x minus y. And then I would add the 1. So that would be a negative 4. Nope, sorry, that would be a negative 2. But then we can't have a fraction. So the way you get rid of that fraction is you multiply everything, the whole problem, by the denominator. So I'm going to multiply everything by 4. So this would be negative 8 equals 1x minus 4y. Again, we don't like a ton of negatives, but we also don't typically love a leading negative. So if you wrote it negative x plus 4y equals 8, it's okay. If you wrote it like this, that's okay. If you wrote it like this, that's okay. I'm not super picky on those. All right, 11 and 12, they ask for slope-intercept form to write the equation of the line through each pair of points. So we're going to start by finding the slope. Remember, x1, y1, and x2, y2. Slope formula is y2 minus y1 over x2 minus x1. So it's going to be 3 minus 5 over negative 3 minus 1. So that's a negative 2 over a negative 4. And negative 2 over negative 4 is a positive, and reduce it. So 1/2 is going to be your slope. And then it says use slope-intercept form. So you can start with it in point slope, or you can start with it in slope-intercept. It's kind of however you prefer to solve it. If I use this point and this slope in point slope form, it would be y minus 5 equals 1/2 times x minus 1. And then to put it into slope-intercept, it would be y minus 5, distribute this 1/2 x minus 1/2, and then your last step would be to add 5. So y equals 1/2 x plus 4.5. And that would be your slope-intercept form. Number 12. So you have x1, y1, and x2, y2. So it's going to be y2 minus y1 over x2 minus your x1. So that's a -3, and this would be plus a positive. -2 plus 4 is 2. Okay, so your slope would be a -3/2. And then you just pick which point you want to do to put it into point slope form. So y minus 1 equals a -3/2 times x minus a -4. You know what? Nope. I would probably use the other point. I would use this one because of the 2. I'm going to use the other one. You could do it with that one, but it's just going to be a little less nice to break down initially. So y minus a -2 would be y plus 2 equals a -3/2. And then x minus a -2 would be x plus 2 also. So that when you distribute this, y plus 2 equals -3/2 times x minus -3/2 times 2. Those 2's will reduce to 1, so it's just going to be, -3. And then you would subtract 2. So y equals a -3/2 times x minus 5 would be your slope-intercept form. All right, 13, describe each translation. So remember, inside is what moves left and right, but opposite of what you would think. Outside moves up and down and the same as what you would think. And then just remember, when there are absolute value bars, you get a V shape out of that. Okay, so this one is saying essentially x plus 3 on the inside is you are going to move 3 to the left, and then -2 is going to be 2 down. So if I go 3 to the left, 1, 2, 3, and 2 down, that puts me here. And then remember that a term out in front is what determines kind of the slope of the lines, if you will. So up 1 over 1 in both directions is what you would be doing. So it's going to look like that. Okay. 14, there's nothing here. It's essentially saying +0, so you're not moving up and down at all, and this -4 is going to move you to the right 4. 1, 2, 3, 4. Again, nothing out in front, so it's just going to be up 1 over 1 in both directions, which looks like this. Okay. All right. This one I'm going to talk you through, but I'm not going to be able to show you my graphing calculator right now, but I will give you all the steps to do it. It says the table shows the enrollment at Westside High during the years 2004 to 2009. Notice we're not going to plug in these numbers. Okay, we're going to plug in 1, 2, 3, 4, 5, and 6. So make a scatter plot and draw a trend line. On this one, your first step is to go stat and then edit. Okay, so that you can put your list in. So L1 should be 1, 2, 3, 4, 5, 6. L2 should be these numbers that you see here for the enrollment. And then step 2, first of all, make sure that your plots are on. Remember, that's in, if you hit Y equals, it says plot 1. You want a black box around that. So when you go into Y equals, make sure your plots are on. Step 2 then will be to graph it. Well, maybe step 2 is to turn your plots on. Step 3 is zoom 9. We'll graph it for you. So then step 4, you're going to go stat. You're going to calculate. And then you're going to do the linear regression, linreg. I don't have my calculator in front of me right now. I want to say stat calc, is it 4 or 5 maybe? Then your next step, you'll go alpha, trace, shoot, I really should have gotten my calculator out. Ask a neighbor if you're not sure. I can't, I need my calculator in front of me and I don't have a calculator. I'm at home and I don't have a calculator at home here with me, at least not a graphing calculator. Oh, wait, here we go. Let me see if I can pull it up real fast. Okay, I think you just go alpha, trace, and then enter, really. You're going to store it as y1. And then your last step is to calculate. You will see let's see. So make a scatter plot. This is the one, it'll look something like this, right? You'll have your window. Your max and min, you hit window for that, right? If you hit window after you've graphed it, and I like to graph it after you've stored. So I always remember I draw my line in where it hits here and here, and then I plot my points around that. So like down here, here, kind of on, a little bit above, a little bit below, like that. And then your window is 0.5 to 6.5 and 1544.77 and 1838.23. So that kind of gives you your range. And then the equation of the line of best fit, when you do the calculate part, remember, it gives you all of your values, excuse me. So y equals 42.11x plus 1545.93. So then estimate it, the enrollment in 2015. Now, this is a little bit tricky because your year one is 2004. So 2015 is year 12. Okay, so we're going to say where x equals 12. So you're going to plug a 12 in here, and that gets you 42.11 times 12 plus 1545.93, which equals 2051.25. So the enrollment would be about 2051 people for that one. If this is a struggle for you, come see me on Monday after the exams, or ask a neighbor. Someone in the room can talk you through that process with the actual calculator in front of you. Okay, 16. This one says graph the line, and we have y equals a negative 3x minus 1. So when you graph this, you are first graphing your y-intercept. This is slope-intercept form. So you're going to plot the negative 1 first. So from 0, 0, you go down 1, right? That's this. And then from there, you'll go down 3, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. You could also go the other way with it, up 3 and left 1. Your graph ends up looking like that. Okay. And then 17, this is the cover-up method that we did. When it's in standard form, you can do the two equations. So 2x equals 12 and negative 3y equals 12. Remember, it's essentially saying for this equation, we set y equal to 0. That'll be your x-intercept. For this equation, we set x equal to 0, which would be a y-intercept. So you solve both of those, and you get x equals 6. So on the x-axis, 1, 2, 3, 4, 5, 6. Okay, so that's your first one. Your second one, divide by negative 3, and you get y equals negative 4, and that's your y-intercept. So again, from 0, 0, you're going to go 1, 2, 3, 4, because it's on the y-axis. But then your line is just connecting those 2 points. So take those 2 points, draw a line through them, and you're good to go. Okay. Okay. Number 18. This one says, and here's some multiple choice questions for you again. Number 18, which phrase could not describe the negative square root of 196? Think about a rational number is any number that can be written as a fraction. So if you were to plug into your calculator the square root of 196, Okay, this is saying if you take that square root, first of all, that would be 14, right? So this is saying the opposite of 14. So this is equal to negative 14. That is a rational number. We can write it as a fraction. That is an integer, a negative whole number. But this whole numbers are 0, 1, 2, 3, 4, so on and so forth. That is not a whole number. Negatives are not whole numbers. And because of this negative out in front, then B would be your answer. Okay, so that is not a whole number. Okay, 19. Which equations have graphs that are perpendicular? So all you're really looking at here is the slope. Okay, so here's the slope of the first line. The slope of the second one would be 1. The slope of the third one is 3. And the slope of the last one, remember, slope is whatever comes right before the x. So that would be 1/3. So if you recall, perpendiculars are opposite reciprocals. So the two slopes that are opposite reciprocals would be the -3 and the positive 1/3. So your answer would be 1 and 4, which is letter D on that one. All right, moving right along. Okay, number 20, which relations are functions? And if you recall, a function passes the vertical line test. So this guy does. This guy also does. This guy does not, right? So this is not a function. This guy also does not, so he's not a function. So 1 and 2 would be your functions. All right, this one says, which line is parallel to y equals a -1/2 x plus 4? So parallel would be the same slope, okay, but a different y-intercept. And if you look at the setup here, the only one that has the same slope, this is a slope of 2, this is a slope of -2, this is a slope of -1/2, and this is a slope of 1. So the only one that has the same slope, and yet it still has a different y-intercept, would be letter C. All right, that is chapters 1 and 2.